There's one basic way to address the idea of what an acidic or a basic or a neutral solution is, and then we can apply that to specific circumstances. But the root idea of what it means to be acidic, basic, or neutral is some comparison of your amount of H3O plus, which is the same as H plus. When you put H plus in water, you get that H plus stuck to the water and you get H3O plus, the hydronium ion, versus OH minus. And I think that one of the things that is least intuitive, or at least a common misconception, is the idea that an acidic solution only has H plus or H3O plus, and a basic solution only has OH minus, when in reality there's a direct relationship between them. It's an equilibrium situation, and you can't have one without the other. And you've got, as a quick note, Kw, the equilibrium constant for water, is the concentration H3O plus times the concentration of OH minus. All right? This is a number at 25 degrees Celsius. That number is 10 to the minus 14th. And the key part there is that number is not zero, so that number can never be zero, and that number can never be zero. And that's the basis of the idea that as one of these numbers goes up, it becomes more, in this case, acidic, or if this number goes up, it becomes more basic. And in order for this number to go up, this number has to go down. In order for this number to go up, this number has to go down. It's an inverse relationship. But again, neither of them gets to be zero. That's not how it works. So you will always have H3O plus in a basic solution, and you'll always have OH minus in an acidic solution, and you'll have equal amounts of them in a neutral solution. So I want to make a quick table that addresses that, kind of a summary. We'll set it up on this side here with what it means to be acidic, what it means to be basic, and then neutral. And there's two scenarios we're going to look at. One of them is in general, all the time, and then the other one is in a specific situation, and that is at 25 degrees Celsius. We'll try and squeeze this in some efficient way. And I'll divide maybe right here and right here. So at any temperature, so these are the root ideas of what it means to be acidic, basic, and neutral. And the root idea we mentioned before is that Kw is a concentration H3O plus and OH minus. All right? So what does it mean to be acidic? Well, the concentration of H3O plus has to be greater than the concentration of OH minus, right? That's what it means to be acidic. What else does it mean to be acidic at any temperature? Well, your pH has to be less than your pOH. All right? And you can look at a previous video where we talk about pH and pOH, but this is the power of hydrogen, negative log of hydrogen ion concentration, and the power of hydroxide, the negative log of the hydroxide ion concentration. All right, that is the basics of what it means to be acidic. So what does it mean to be basic? We can look at this same type of relationship. We've got a concentration of H3O plus that has to be less than the concentration of OH minus, and correspondingly, your pH has to be greater than your pOH. And then what does it mean to be neutral? And to be neutral, we just have to have the concentration of H3O plus equal to the concentration of OH minus. All right? And as a result, you'll have your pH equal to your pOH. So this is true at any temperature. And what happens is the K value, Kw, changes with temperature. And since it is an exothermic reaction, as the temperature goes up, the K value actually goes down. So just a little note about equilibrium and how that works. So a specific situation, and this is what most people are used to in terms of numbers and relationships, is at 25 degrees Celsius. What's true? So at 25 degrees Celsius, this is still true. Kw is H3O plus and OH minus. But it has a value, and that is 10 to the minus 14th. So I think if we look ahead, a little foreshadowing is the number 14 there, which is a number that a lot of people recognize in terms of acids and bases. It is still true that your concentration of H3O plus is going to be greater than your concentration of OH minus, right? And what we're saying now is we have a specific number, and that concentration of H3O plus has to be greater than 10 to the minus 7th, which will be greater than the concentration of OH minus. All right, that's 10 to the minus 7th molar. I didn't write that explicitly. At 25 degrees Celsius, your pH has to be less than 7, and your pOH has to be greater than 7. So there's this common idea, neutral. What does that mean? And people will say, oh, this is when there's a pH of 7. That's true at 25 degrees Celsius. At different temperatures, these numbers change, and I don't think that's something that most people know. So looking ahead here, we can come up with these same relationships. We said concentration of H3O plus has to be less than the concentration of OH minus. And now we have a number to go with that. The concentration of H3O plus has to be less than 10 to the minus 7th molar, has to be less than the concentration of OH minus. And so we're going to flip-flop these. The pH has to be greater than 7, and the pOH has to be less than 7. And then our final relationship here, again, your concentration of H3O plus has to be equal to the concentration of OH minus, and that is going to be equal to 10 to the minus 7th molar, all right? And we mentioned a minute ago, like 14 is this number people associate with pH. 7 is the other number people associate with pH. And I do want to mention, if you look at the other video, 14 is not a bound. pHs can go above 14, pHs can go below 0 or below 1 and get into the negatives. And I think that's something else that people tend to miss out on. In this case, then, pH is going to be equal to pOH, and that's going to be equal to 7. All right? And another little note that we can sneak in here is that at 25 degrees Celsius, pH plus pOH has to equal 14. So that gives you some shortcuts. Like if you had a pH of 2, your pOH would be 12, and it adds up to 14. And again, that's because the autoionization constant, the equilibrium constant for water, is 10 to the minus 14th at 25 degrees Celsius.